Okay, we're going to go through something called Graham's Law. This is really simple, but sometimes people will forget the last part. So I think what you need to remember is with something like Graham's Law, you got to remember that in chemistry, we usually don't have things as far as one part. Actually, Graham's Law has two parts. Go ahead and close the door. So, I think you need to remember that lighter gases move faster than heavier gases. You can calculate how much faster or how much slower based on their masses. So let's do a comparison. We're trying to find out how many times faster or the rate for Graham's Law. So let's compare O2 and H2. So if you have O2 and H2, you should expect that the heavier gas, which is oxygen, O2, is going to move slower than H2 because the mass is higher for O2 than this one. But how many times slower or how many times faster? Well, first of all, you have to take care of the masses on those two gases. Masses, gases, grams. So we're going to go with this, which is 16 times 2, which is 32 grams per mole. And then we're going to have hydrogen, which is going to be 1 times 2, which is going to be 2. Now we're going to do a comparison. Now there is a formula for this, but the formula is kind of confusing. What you want to do is you have to do something that is times. So what I would say as kind of a rule of thumb is you're not going to say point something slower or point something faster. You want it with a times. So what you're going to do is you're going to put 32, the heaviest gas, and then you're going to put the lightest gas on the bottom, which is going to be 2. Now if you divide it, you can easily see that it's going to be 16. But remember, in chemistry, you don't do things in one step. You have a second step. You do the square root of this. And the square root of 16 will come out as 4. So now we have, this is called our rate. So the rate is going to be a number. And my rate for oxygen as opposed to hydrogen is O2 moves 4 times slower than hydrogen, or H2 moves 4 times faster than oxygen. Again, we're talking about rates, slower, faster. Heavier gases move slower, lighter gases move faster. Let's go ahead and do one more. We have our fun part usually in classes where you compare CH4, which is called methane. So when you are going to the bathroom or passing gas, that is what methane is. Or you have something called hydrogen sulfide gas, which is rotten egg, which maybe you eat eggs and kind of smells like that. So this is called the rotten egg gas. So in classes, we usually refer to this guy letting something out as called methane man, and this is called the rotten egg ripper, the one that lets out this gas. We can compare the gases here again. If I do a mass of this, it's going to be 12 plus 4, which equals 16. Again, we're doing a mass, molar mass. And then in this case, I have 2 plus 32, which is 34, just doing a mass of that. Again, masses of the gases, that's a mass, or the symbol for mass, grams. And then, again, we go through process, faster, slower, but we put the heaviest on the top, lightest on the bottom, because we want to figure out our rate. And then we're going to go 34 divided by 16. So we got 2.125. Again, we have a second step, so we are going to do the square root of this. And it's going to be the square root of 2.125. So we're going to have a 1.46 rate. And we can do our comparison now. This one's going to move 1.46 times slower than this one. And this one's going to move 1.46 times faster than this one. So that is an introduction into something called Graham's Law. This is pretty much all it is. It is one of the additional gas laws because we are comparing rates and how fast they move.